All right, everyone. Hi, my name is Greg Cathcart. It's been a couple of years since I have done a presentation on APEC, and Tim was kind enough to allow me to present, and it was very successful. So it was a lot of fun, and it's gotten a lot of good reviews. Today, I want to do a presentation on detection, perception, and bias. We will look, before we get to detection, we'll look at human perception and bias in analyzing or essentially evaluating a particular scenario. Both are important in how we guard against bias, and at least we recognize it. And of course, perception, I think you'll find this interesting. To do so, and let me skip through here really quick. I've taken my email out, and that email is available on the Figshare site. I think I've got 51 presentations or something close to it up there. So please feel free to go take a look. And some of these, or most of these, are really abstract. And that's by design. The whole idea is to get people thinking. You know, I've learned in the past, if we can just get people to say, what if, after they have looked at something, it usually leads to good things most of the time. So anyway, let me move to the next slide. And the presentation is presented under Creative Commons 4.0, CC by 4.0. Please cite. It's important that you cite. It is, regardless of whose work that you're reviewing or incorporating into your own. It really is beneficial to cite for all parties involved. Here's my bio: writer, advisor, technologist, company founder, etc. I've been involved primarily with artificial intelligence, and over many years have been extremely interested in artificial general intelligence. That is my wheelhouse, as it were. Foundational physics is an interest, and it is an absolutely fascinating field. At times I wonder if I should have been a physicist. Maybe I could have taken that course, but artificial intelligence has been quite beneficial as well. Currently live in Texas and Colorado, yay UT, and I am actively involved in educational opportunities worldwide, but essentially I guess the greatest accomplishment, as it were, is Anomalous High School, where we took nothing and turned it into an award-winning public charter high school. Check it out if you have time. Presentation background: public interest in unidentified aerial phenomena has grown significantly in recent years, to say the least. It's primarily due to efforts by the United States Congress and related entities, but also the general UAP population as well, to assess whether the phenomena pose a substantial risk to national security. Congress formed AERO, and it was at least some movement towards trying to determine what was going on with UAP. But I think a huge benefit has occurred by those individuals that have taken it upon themselves in the public, journalists, scientists, physicists that have become involved with UAP to really drive this. And it'll be exciting, and it's going to be a lot of fun to see what happens. I wanted to highlight some issues regarding detection of anomalous transit and make it accessible. And these are the role of perception and bias in the detection and mitigation of anomalous transit, the means of detection of anomalous transit, including technologies, capabilities, and vulnerabilities, the possible strategies and technologies required to mitigate anomalous transit. And when I say mitigate, those are the words basically from AERO. Mitigation is, I think, a little bit strong, in my opinion. I really would just say not required to mitigate, but required to fully understand. The role of consciousness in the detection of anomalous transit. All right, additional topics for future discussion. I've got a fairly broad range of interest, but I'll be glad to talk about these at any time. They're not particularly relevant to alternative propulsion. but they are things that are a lot of fun to talk about. Projected realities versus simulations or a dream state. And you can read down through these yourself. The nature and of objective reality, transit within and between objective realities, and the list goes on. If you have an interest in any of these, please let Tim know. And if you want to ask any questions regarding these subjects during Q&A, that's fine too. I'll be glad to take a look at that and talk those over with you. By the way, last night, about 10:30 or so, the fireworks started. They let up about 2:30 in the morning. And here in Texas, people take 4th of July, I guess, seriously. But I think a bunch of kids were out and just down a couple of blocks down the street. Why the police were not called, I have no idea. But anyway, it did manage to keep me up most of the night. So great fun. All right, let's talk human perception and let's talk some baseball. And hopefully what I'm seeing on the screen is something that you guys can see as well here. There were a couple of conversations that started with my father-in-law, who is a PhD or was a PhD. He's passed away several years ago now, and a lifetime employee of Sandia Laboratories. We had exactly 2 discussions regarding physics. One was baseball, and we'll cover the other one in just a minute. But he came in a conversation that we had when he came to our house for dinner. He was explaining to me, we were talking baseball, and he said, I've seen a fastball rise. And I said, Charles, you have a PhD in engineering mechanics. You know that fastballs can't rise. What are you talking about? He said, I've seen a fastball rise. And I said, all right, Charles, you know what? I'm going to take a closer look at this, and I'll do a little research and see what I can determine. Anyone else see fastballs rise? And it turns out they do. Professional baseball players see it quite often. And it has to do with human perception. So let's talk about it just for a little bit. There's something called a four-seam fastball. You're looking at a baseball here. And depending on how I grip this, for instance, this would be a grip that's required to throw as you spin it, to throw a curve, what we used to call a curveball. Then there's the two-seam fastball, which I've rotated the ball. So therefore we have seams facing and 2 seams, which I'm throwing, right? And then I've rotated the ball. So there's a 2-seam. Then I rotate the ball, and here's a 4-seam. And this is where the batter is going to be facing a ball that is being thrown. It's the fastest ball that can be thrown, 4-seam fastball. And as the ball leaves the hand, it begins to counter-rotate, to rotate away from the batter, which causes an unusual effect, which human perception has a problem with. And we'll talk about that in just a second. All right, first of all, the distance between, and this is applicable to the rest of the application, so I'm not just, please bear with me here. 60 feet 6 inches from a mound, the baseball mound, to the home plate. And when a fastball is thrown, the fastest recorded fastball was thrown by Nolan Ryan, and it was 108 miles an hour. Now, that's really fast, in case you're wondering. And it's interesting in that, and let me bring this up a little bit. It's interesting that, first of all, the human being can throw a baseball that fast, but there is a 1 millisecond window when you throw a ball that fast for the pitcher to release the ball. 1 millisecond. 1 millisecond too soon, it's ball high. 1 millisecond too late, it's ball low. But if he hits that window, for instance, in Nolan Ryan's case, he can throw a strike. It takes 5 seconds for the signal to go from his brain to the release of the ball, which essentially means that he has to predict. And this is one of the amazing things about human perception and the mind, in that to a 1 millisecond window, the human mind can predict and say, all right, here's where I need to release this ball. Now, that's the plus side on human cognition, but it gets even more interesting on the batting side of human cognition. A 108 mile an hour fastball travels at about 150, 158.4 feet per second. the distance has to be reduced based on the release point of the ball, because as the pitcher throws the ball, his back foot is on the pitcher's mound. He releases the ball. So it's cutting about 5 feet off, especially when you're talking about someone that's tall as Nolan Ryan. And so it turns out that the batter has about 0.395 seconds, right at 0.4 of a second, to be able to, and you can read the points at the bottom of the slide here, about 0.4 of a second to be able to identify the ball, to identify its trajectory, to decide to swing, to follow through with the swing. And the problem is human perception does not allow him to do that at that speed. So the batter then has to really take an educated guess as to when the ball and where the ball is going to cross the plate in the strike zone. But there's a problem here. As the seams are spinning backwards, as the ball's released, the seams are spinning backwards. And what is happening is the ball is not, because of aerodynamics, it's not rising. It can't rise, but it will drop a tiny bit slower than it would have had it just not been spinning. That's working against the batter. The second thing is the human visual cortex is not designed to track something this small at that speed. And so the batter can't see actually what he's trying to hit. And what he's seeing is what the brain is providing him, what the visual cortex is providing him, filling in the blanks, because he really can't process it that fast. So the ball comes in. And the amazing thing about the batter is he has to ignore his own perceptions when he swings at that ball. His mind is telling him where the ball is, but the problem is it's not. And so his is an educated guess at the professional level, certainly. And he may be right, he may be wrong. He doesn't know. But the point is he's swinging before he's actually able to compute where the ball is going to be. Just one of those amazing facts about human perception. Keep that in mind. We'll get to it a little later. All right, bias. And here is another conversation that I had with my father-in-law. None of this was classified, obviously. So anyway, there was Sandia Laboratories had an open set of hearings, or not hearings, but an open presentation to the public, where they brought in individuals that were language experts, they were artists, they were designers, they were scientists. And what they were trying to determine is how to send a message for 10,000 years. How would you do it? How would you create a message that could be openly seen and last for 10,000 years, knowing that language is going to change to the extent that it would not be recognizable? I have enough problem with Chaucer, let alone 10,000 years worth of human development and language development. And so the idea is they got together and they said, all right, we need to build something out of earth and stone. And at the same time, we need to not have essentially any visible writing. And we will plant this thing somewhere, and underneath it, we'll do the nuclear waste disposal, because we don't want someone showing up to dig and to pull up radioactive material. So they came up with all these incredible designs. And I was listening to him talk about how they might do this. And it turned out that, as I was thinking, there is a place like this already. And yeah, we did this. So what I did was I went and I said, all right, let's take a look at the most famous. And again, this is basically we're looking on the AI side. Where's the famous structure? We've all heard of it. It's the Giza complex in outside of Cairo, Egypt. And we said, all right, how could that reflect a message? And this gets really interesting. We decided to take a look. I'm going to fast forward through or go to a second slide. Take a look really quick. This has to do with bias. And we looked at this section, and you can see it on a previous view right here, where we had, if you look at the top image, the right-hand side, see the green box that's transparent. We decided to leave the Great Pyramid alone. Why? Why would we do that? We're not going to do that. So we looked at another area of the Giza complex, which is a causeway associated with the Sphinx and some temples and this type of thing. And what we did was we pulled the top off. It looked like this middle image right here. And what we said is, what in the world, if that were a message, what could that represent? And so I developed a methodology that involved, it's called simple and process primitive scenario generation. And what we did was we took a meta approach to what we were viewing. And we said, all right, let's look at the bits and pieces of this. And we looked at each individual object that was uncovered when we removed the roof, so to speak. And we said, what could this possibly be? And so the idea is we identified the objects. We then turned around and looked at combinations of how these objects were associated. You can see it here on the left-hand side. There are areas of interest within this complex. And we said, all right, what could this possibly be? So we looked at the relationship of these items. And again, this is a very early 1998 version of very simple neural networks, right? And so we were using some back propagating stuff, and we were saying, all right, can we look at the relationship of these items together? And then we would put these before an expert, and the expert would say, this is what I think. This is what this looks like. And incredible things came out. It was very interesting. But the lesson learned here, I've listed some of these right here. And that would be, let me go back to this other slide. What we found was that experts were varied in their opinion, and it could be anything. It's kind of like trying to analyze an ink blot, because it could be anything, right? There's nothing that is really defining what it is. But it was a very interesting approach on a meta level to be able to look at symbols, to be able to look at those symbols combined together to make a process, and then that process being reviewed by an expert, and then the ensemble voting among experts being able to say, all right, this is what we think this might be. So you can see the bottom, there was light, there was electromagnetism, there was harmonics, there were, you can just review these for yourself, but it seemed extremely interesting. However, we also, and this was the biggest learning part of this, not that have we identified some process? No, that wasn't the idea. The idea was, is there what have we brought to this analysis that would help in further learning of how to implement systems like this? And what we found was a boatload of bias. Why did we find bias? Well, we were looking at this, and various experts were looking at this from the standpoint of their own backgrounds. It was interesting hearing Joel talk about Heim saying that you can't bring complete subjectivity to an analysis, and you can't. And we learned this. It was an interesting experiment. It was a lot of fun, but we did determine that it's impossible to keep bias out of any type of analysis. For instance, in the development of a system like this, data, there was bias in data, there was bias in design, there was bias in coding mechanisms, there was bias in testing, bias across the board in the way that this system was developed and designed. Whether or not there was any truth in what it put out, the fact was that we knew it was subject to error. And however, that being said, we also learned that, and if you can see this, ideas generated basically from this analysis in subsequent years, it's okay to take a look at the ink blot sometimes and bring your subjectivity to it and see what comes out. And it was a very beneficial exercise. And again, you can take a look at these items and let me know what you think at your own time. The second system that I want to highlight doing bias was actually a graduate assignment in which I was asked to develop a diagnostic system for healthcare. And it was a particular diagnosis. We won't talk a lot about what that was. And we learned something extraordinary, I mean, in my own opinion, because I really knew nothing about medicine. But when a physician sits down to take a look or with a patient to diagnose, initially if it's not obvious what's happening and there has to be some investigation. They use a combination of negative and positive predictors. I've talked to a physician recently that said many of the physicians that are graduating now are heavily reliant in their practices upon a positive prediction, which basically is statistical prediction saying that it's likely to be this, but they're not paying enough attention to identifying what it's not. And so I took a look at it back then and was quickly able to determine that both of those approaches were necessary. And I created what was referred to by my professor as the perfect negative predictor. Now, if you've done any research, you understand how funny this is, because I could not tell you if you had this certain condition, but I could sure tell you if you didn't have it. And I'm not sure how useful that was. Obviously, it was heavily weighted on the negative side, but it was a learning experience. So bias is with you always. So let's get into the detection part. All right, move forward here really quick. All right, detection of anomalous transit. I have to get a little closer to the screen here, so bear with me. Any object that distorts, reflects, emits electromagnetic waves, any object that distorts, reflects, or emits acoustic waves or vibration, any object that creates an observable heat signature, any object that affects the external environment in an observable way. What can be detected? How can it be detected? Eyesight, electromagnetic wave signatures, acoustic wave and vibration emission and detection, spectral imaging, environmental effects, and other. Where can it be detected? Air, land, water, and we're specifically talking about UAP here, right? Transmedium phenomenon and other. And where can it be detected? At entry points, exit points, and transit points. So let's move forward. Detection of anomalous transit, methods of, and how this fits into or how it's affected by methods of intelligence collection. There is open source, there is human intelligence, cyber, communications intelligence, spectral imagery, visible imagery, synthetic aperture radar, radar intelligence, acoustic and seismic, telemetry, foreign instrumentation signals, radar signals, and other electronic signals, materials, biological and medical, biometrics, and material acquisition. Now, in the best of worlds, all of these should be applied to the detection of anomalous transit relative to UAP. Today, we're just going to look at a couple of these: spectral imaging, visible imagery, synthetic aperture radar, and the active interrogation or radar, active interrogation by radar for intelligence gathering. All right, operating modes. Radar breaks down into search radars, tracking radars, object identification radars, imaging radars, multifunction radars, and microwave vibrometry. Vibrometry is an incredibly interesting subject in that you may hide yourself, and think about some recent events internationally. You may be able to hide things, but sometimes it's a little more difficult to hide the vibrations that they create. And we have technology that allows us to, based on vibrations, and these things may be underground, they could be in areas where they just can't be seen, but their vibrations can be detected, and they can be detected from a long distance. So including the identification of specific machines that are creating vibrations. So there's something called a vibration signature, which allows us to catalog various pieces of equipment or various processes that we can then catalog and have those signatures available, so that when we interrogate a target for vibration signature, we're able to identify the parts and perhaps the processes that are operating within that target. Types of radar: over the horizon, VHF, UHF, L-band, S-band, C-band, X-band, laser radar, and synthetic aperture radar. We'll move on. Operating modes. Search radars transmits radar imagery through a volume of space. We all are familiar pretty much with how this works. You've seen the rotating things that go 360 degrees and you see the surrounding area. Early radars were like this. Tracking radars, which keep a beam on target throughout the radar volume coverage. They're used to identify where the target is and where it's going. Object identification radar is used to obtain a unique signature from the target, used to determine mission purpose of the target and discriminate among targets. Examples include space object identification radars. And yeah, there's such a thing. And so these radars are located across the country, and they basically point up in the air, and they're able to identify any object that is in orbit above the Earth. They're able to identify when new objects enter. They're able to identify when objects change course. And as you can imagine, perhaps, they're able to identify other objects as they enter that space. Imaging radar is used to create a picture of the target. It may be used to create high-resolution images of the Earth's surface or an object, and that would include synthetic aperture radar. Multifunction radars, which combine the above. Examples would include search and tracking radars on military aircraft. Microwave vibrometry, we talked about that briefly. So there are many types of radars that can be used for identifying objects. Let's move on. You can take a look at this at your leisure, but one thing I wanted to discuss were the combinations of radar technology. And what is happening now is, as an object is identified, let's say it's a new object or it's one that's known, right? Its initial detection is done by long-range radar. Then a different type of radar is going to take over range and velocity measurement. A different type of radar is going to take over high precision tracking. A different type of radar will do target identification and imaging, and other types of radar are available for determining stealth. So these are wrapped together in a network. They're integrated, and then they are centrally controlled. And the new thing now is an AI augmentation of that control, AI analysis and control, which basically takes the data that is associated with this network of radars, and it turns around and analyzes it and provides information directly to those monitoring these systems. So you can imagine the effectiveness of this integration. There's reduction in errors, higher reliability. It's integrated for air defense, prioritization based on scenario, which is very interesting when you think about it. We talked about scenario generation earlier, but if you have scenarios that are predefined and the AI is able to determine that the scenario is actually occurring, then at that point, it is able to make decisions on its own. We'll talk about this in just a moment, but it's important. Frequency diversity, there's a increased ability to deal with an object based on using several different types of radar. So this is important. Autonomous AI, we talked about that just a moment. But again, prediction of target behavior is another thing. You have a scenario, then we predict target behavior, and also the filtering of clutter is another thing that AI can do very well. So it really does make for a formidable means of dealing with those signatures that have been identified previously, as well as those that are unknown. FLIR technology, forward-looking infrared. It's a type of thermal imaging that creates an infrared image of a scene without reading or moving sensors to scan the area. It uses a thermographic camera to detect infrared radiation emitted by objects and convert that into a visible image. We've all seen Tic Tac videos. We've seen, and we'll talk about a couple of these in just a minute. It's helpful in conditions where visibility is impaired or limited. It's passive and does not create an EM signature, but for targeting, it must be matched with an IR illuminator or a laser designator to target and track. Now, this is really important because when I first, and we'll talk about this in a minute, when I first saw some of the films of the response of the Tic Tacs when they were exposed to FLIR, it didn't make sense to me at first. And then I realized that, wait a minute, there is an EM signature that they are picking up, whoever they are, whatever they are, and they're responding to it. And that would be IR eliminators or laser designators. Military usage, FLIR, surveillance and reconnaissance, targeting and tracking, pilot vision enhancement, search and rescue, and there's many others. All right. The gist of, or the most important part, I think, of this presentation is the idea of autonomous, tunable resident meta surfaces. That's a mouthful. So I created an acronym, just what the world needs is another one, ATRMS. And so short for autonomous, tunable resident meta surfaces. What are they? A tunable resident meta surface is a thin two-dimensional array of sub-wavelength structures whose electromagnetic properties can be adjusted dynamically. Tunability can be achieved by changing material properties or structures, allowing control over resonance and frequency, phase, and amplitude. What does that mean? It means that a resonant metasurface is able to, if it's exposed to an EM signature, if it's exposed to any electromagnetic wave, it's able to analyze that wave and then turn around and react accordingly. And you'll see how this plays out in UAP in just a moment. Active materials, active materials which can be manipulated electrically through magnetism, heat, pressure, or light. With the exception of light, this is what we typically would call multiferroic manipulation. But we add light, it results in a shift of resonance frequency. Potential for real-time structural reconfiguration, material properties, phase change, or mechanical. So again, real-time reconfiguration by the material itself, and a potential for external control or autonomous response. Potential uses: dynamic metasurface for radar manipulation, sensing and imaging, and other. So what we have in the diagram here is a surface at T1, time 1, a metasurface, and at T2, that metasurface now based on input has changed, and it's done so automatically. So to give an idea, EM interaction with tunable resonant metasurfaces, here the diagram is showing surface at T1. It's being irradiated by an electromagnetic wave coming in. In real time, it's analyzed. The surface T2, which is time 2, radiates back if it desires, or it can be used for cloaking, absorption, redirection, scattering, spoofing, or other. And this basically makes an object, if it is coated with this type of material, pretty much invincible to electromagnetic interrogation. And I'm not invincible, but more or less uninterrogatable. Let's put it that way. All right, case study, the Apache Longbow incident. On November 6, 2018, a U.S. Army AH-64 helicopter encountered 3 unidentified aerial phenomena during a training flight in Arizona. There's videos released publicly. I've included a link here. The video shows 3 unknown objects flying in a loose triangular formation. The 3 objects suddenly begin moving erratically around each other while maintaining a steady eastward trajectory. An analysis by former U.S. Air Force personnel concluded that it was anomalous. The objects were calculated to be moving at approximately 1.28 Mach, and their movement during flight were determined to be impossible for any kind of drone or other aircraft in the current or known inventory of the United States military. You can find the video released by the DoD here. Here are the links. All right. These are some single screen captures of what occurred as the pilot was coming down the runway, or essentially in a helicopter is getting ready to take off. He doesn't have to, he can obviously, but he is at the end of the runway. As he's coming out, he sees these three objects in the sky. They're bright. They are three, and I will show you pictures of these in just a moment. Here's the initial screen. They are three, and you can see them here. If you look inside the red box, there are 1, 2, 3. And he's seeing this, and initially he identifies them by sight, as it were, saying that, you know, what do you see those three really fast-moving planes up there? And you can hear another voice say the A-10s or something, the F-16s, whatever. There doesn't seem to be a lot of concern, but the pilot's really cued in on it. And what happens in the next slide is that you see, and let me run back one real quick so you can understand. This is targeting. So what's happening is the pilot is looking, and as he is looking, he's creating an electromagnetic wave. So here we have it. The next slide over shows the reaction that occurs between the three, and I'll show you a little better image here in just a second of what's happening once these are illuminated. Next, you see two objects. Next, you see in these three, we see the original three objects. After they are illuminated, again, here's the pilot's side, we see the objects bunched together immediately. Then we see them, 2 here, 1 here. They begin moving, and as they're doing it, so we've got trajectory, we've got response, what is happening is that, and let me move, well, I've got a slide to show you in just a second. What is happening is they begin rotating, they begin melding, they begin taking actions that are seemingly impossible. So essentially I've come up with two possibilities here. One is based on a case for interdimensional transit. That's more along the lines of things that might be interesting from that perspective. There's another where we talk about, or I talk about, tunable resonant metasurfaces. The analysis that I did involved Fibonacci. Yeah, I did that. That was interesting. Potential EM response behavior, which we'll talk about. Radar interference. We were looking to see, okay, is there an issue where radars actually interfered and caused some kind of optical bizarre thing? Optical phenomena, internal shape patterns, and higher dimensional perspective. And we'll talk about these. Let's go through them. All right. If we assume that the anomalies behavior, there's no alternative explanation for their behavior, that it truly was anomalous, radar and optical phenomenon have been ruled out. We assume that we're witnessing a projection or reflection of a higher dimensional reality. And this is backed by what physicists believe should be seen if our reality were to be penetrated by wormhole, as it were. Images support the perspective of higher dimensionality as viewed in a lower dimensional environment, lower dimensional perspective. The projections may reveal independent objects or pieces of a greater whole. Projections may be intentional or not on the part of the objects. Projections are most likely an artifact of anomalous transit. Now, again, we're assuming it's not anything that can be explained terrestrially, as it were. Projections may provide essential clues as to the origin of anomalous transit. There's a possibility of EM interference affecting the objects during transit. Remember that. Possibility that the astute reader will recognize unique possibility related to the images captured in the Longbow incident. It may be possible to stitch together internal patterns reflected by the objects in the 200+ slow motion frame video. These are available, and it served as the basis of much of the analysis here, but it proved to be very, very interesting. I anticipate that the patterns will be fluid and they'll morph over time. And the patterns will morph between 3-dimensional and 4-dimensional representations. Why? Because if a wormhole has penetrated our own reality, or our own part of our three-dimensional space, this would be expected. Essentially the amorphous or blob configuration that we're looking at here, this circle furthest to the left here, would represent a three-dimensional perspective of a four-dimensional object. But the geometries that become very interesting here, a rectangle or square, here a triangle, these would represent the structure of the wormhole opening on the other side. Now, this is predicted by physicists. That's exactly what was seen. And so it's very interesting that that this might actually be. It's the best case I've ever seen for seeing a wormhole that it has penetrated our own environment. Let's move on. I'll let you read all the bullet points at your own discretion. Higher dimensional transit can occur one of two ways, basically through a manifold. This is a very simple representation of a manifold. This is a cross-section of the manifold. Can occur through the manifold or through or along the manifold. And so that's the basis of that. How to make a wormhole. And Jennifer Nielsen made a presentation a couple of weeks ago, where she talked about constructing the possibility of constructing a wormhole. Physicists agree that there are three ways: the Einstein-Rosen bridge, Morris-Thorne bridge, or an exotic energy bridge. These are interesting in their possibilities. General relativity allows all three. It comes out in the mathematics. However, for instance, the Einstein-Rosen bridge is incredibly energetic and highly unstable. The entrance of any outside interference would cause it to collapse. It's also inside the event horizon of a black hole, which is you first, not me. But it does create some challenges. Thorne and Morris came up and said, all right, we could do this, but we don't need to be within the horizon of the wormhole. There's no singularity problem here. The entrance is outside the event horizon. It's stable with minimal effect on individuals or matter passing through it, but it does require exotic matter, exotic mass, which violates the laws of momentum and energy conservation. And that's just the beginning. Very unlikely that a Morris-Thorne bridge is going to be achievable. But the exotic energy bridge is a little different. If negative matter or negative energy could be made at scale, then it's possible that this could be done. It's the scale that matters. There's the Casimir effect, which we have seen the creation of negative energy. The issue being there is being able to scale it up. Negative energy is a reality, but it isn't easy to scale, requires a solution for quantum gravity to implement the bridge. So when you get that solution to quantum gravity, let me know, and we'll see if we can move forward. No small task. All right, what would higher dimensional wormholes look like from our viewpoint? They speculate an extremely bright light at the exit part of the wormhole, possibility of observing geometric shapes morphing in and out of blob-like structures visible through the wormhole throat. Geometric shapes would represent the wormhole's entrance structure on the other end, possibly. Or the possibility of observing multiple wormholes simultaneously for the purposes of stability. Now, what's interesting is in this case, all of those conditions were met, every single one of them. Now, when they were targeted, when they received EM signature, what happened? Well, typically for a target that's receiving non-UAP, countermeasures would include erratic maneuvering, manipulation of return signals. We can do that with radar right now, including jamming or spoofing, or just getting the H out of D, it's escape. And so you see that in these pictures. These are a little better. Here's the three left side, the three objects that are in the process of being targeted, right? They begin to move erratically. Here they are again, these three that have, and remember, if you look up to the right-hand side here, the targets are moving counterclockwise, clockwise, in just circling, melding, separating. At times, one will disappear, two will be visible, one visible, two disappear, all three visible, all three melded. It's just an incredibly interesting thing to watch. So reconfiguration and response. Remember, we talked about tunable metasurfaces. Cloaking, they disappear. Absorption, redirection, scattering, spoofing, or other. And I think several of these occurred during this event. All right, case study, the USS Jackson video, case for tunable resonant metasurface. In 2023, Tic-Tac shaped USPs, 4, I believe, were encountered off the coast of California by the USS Jackson. That's a picture of it in the lower right. Multiple craft were detected by radar and targeted by FLIR. And remember, we said earlier that to target with FLIR, you're going to have to create an electromagnetic signature. The craft exhibited coordinated behavior and appeared to avoid being targeted and tracked by FLIR. So what happened? This is a recreation. These are images essentially that I've recreated based on the video itself. You can find the video. It was released by Jeremy Corbell and George Knapp on weaponizedpodcast.com, I think is what it was. But anyway, it is real. But what gets interesting here is look what happens. This is a thermal image, but it's being targeted with EM, right? So it's essentially the white dot represents targeting, and the black dot represents the tic-tac, what's being imaged or what's being targeted. So you see, at first we have basically a hit on target. So what happens? The tic-tac immediately moves lower to the right. The targeting comes down, tries to acquire again, tic-tac off to the right. Tries to acquire again, tic-tac off to the right. Targeting shifts to the right, tic-tac off to the left. Targeting follows the tic-tac back to the left. These lower two show greater distance between the targeting and the tic-tac itself. So what you're seeing here is motion in almost every direction as the tic-tac avoids the targeting once it has identified the fact that it is being hit by an electromagnetic wave signature. Sounds like a tunable resonant metasurface to me. Here's a diagram that just shows what this might look like. I have no idea. I've never seen a tic-tac up close. I don't know what it, but anyway, obviously it's looks like a tic-tac, right? So if it's designed, if it's covered with a tunable resonant metasurface, then again, it's going to be able to analyze immediately and then determine a response based on the electromagnetic signature, which it is, or wave that it is illuminated with. So again, a tunable resonant metasurface, it's an array of subwavelength structures, which basically are used to analyze what they are being irradiated with, and then to change themselves dynamically in real time. So I think, in my opinion, I think this is probably what we're seeing when it comes to the tic-tacs and their reported ability to cloak, their reported ability to evade detection. It still doesn't explain the 5 observables, right? Which are important as far as the ability to be transmedium, the ability to seem to travel at superluminal velocities, and we can discuss. Actually, you can see the 5 observables that are listed in this presentation. Both incidences, this is the conclusions. Essentially, both incidences show a strong correlation with the presence of autonomous tunable resonant metasurfaces. The technology could be a product of human intelligence or non-human intelligence. The technology is well within the capabilities of a few major nation states, including the United States. Things to carefully consider: perception, back to perception. Remember the baseball. Are we seeing what we think we're seeing? And bias, when we look at these scenarios, is it us? Is it an adversary? Is it human intelligence? Is it non-human intelligence? Or is it real at all? And so these are questions that we need to ask ourselves as we look at these case studies. Last thing, sometimes the things that are not said are as important as the things that are. Pay attention to dialogue associated with any video that you see of UAP, and you'd be surprised what you may learn. Let's move on. All right, consciousness and phenomena, the detection of UAP. It's a really interesting area, and it is one that seems to be gaining prominence within the UAP community. I don't quite know what to think about it at times, but let's talk about it for a second. The role of consciousness in the universe. Hey, here's a big question. So I have an opinion, but I believe that basically consciousness arises naturally. It emerges from the integration of future predictive and past corrective utility with the present. And I've identified this in a presentation called the discrete compressed time conjecture. You can take a look at that on Figshare. The geometry of neuronal firing patterns within the human brain reflects how we integrate the future, present, and past in real time. That each, and this again, I'm proposing that each dimensional geometry identified within the discrete compressed time conjecture will have an exact geometric counterpart reflected in neuronal firing. The neuronal firing geometries will be limited to a maximum of 7 dimensions and interpreted in a 10-dimensional representation. Basically, we're generalizing the past, present, and future, which is an extraordinary accomplishment of the mind, in my opinion. If you've ever tried to think of the future, the present, and the past at the same time, it's a very interesting, complex procedure. But the fact is that we generalize this, and we typically break things into a representation of present and future and a representation of present from past. That consciousness will appear as a fundamental element of the universe due to future predictive and past corrective utility in the universe itself, without the universe being necessarily sentient. People say, oh, the universe is conscious. I don't know. But I would say that it's very possible that if the universe has certain elements, a certain backbone that takes into account future predictive utility, past corrective utility, and present, that the generalization of these within the human mind would interface with the universe at large. So maybe that's where we are tied together. That consciousness may be projected through compression, through a compression mechanism. I talked about this in the DCTC, and that consciousness may be projected across realities. Now, in the DCTC, I talk about the possibility of multiple realities, really all being tied together and being nested. In other words, they are part of the same structure. There are just multiple dimensions of reality. The origin of consciousness, again, in this slide, I get into some of the geometries. We're about to run out of time, but let me move through quickly because there's a couple of things I want to say. Here is an example of the structure of the universe under CT, and then we have future predictive, present, past corrective. These are 3-dimensional representations. There's 1 dimension of time. The idea, the assumption being that that 1 dimension of time is discrete and that it is manipulable through a compression or dilation mechanism. And I talk about the possibility of that being done physically and generalized as well. And essentially, here's the universe. Here's how we perceive it. Here's how we generalize it. And then I want to talk about just briefly a paper by Ryman et al. Clicks of neurons. And essentially, this is, I think, and here's the reference to the right, citing it on the right-hand side, lower right. This is my diagram of an internal structure of neocortical microcircuitry. And basically what this paper showed is that the brain fires when we think anything that is thought within the human mind, that it's done so in a microcircuitry basically of neurons. They detected clicks, and basically what they said, all right, what do we have? We have 729 directed configurations of clicks, right? Each point would represent a neuron. Directed clicks, there are 64 configurations. Cyclical clicks, 40 and 24 configurations, each of these serving a different purpose. And then of particular interest was the simplex dimensions of 3, 4, 5, 6, and 7 in human thought. And it is these geometries that I believe we are using to generalize consciousness and being able to generalize our relationship with the universe as a whole. That's just, obviously, this is highly speculative, but it is something that it makes for entertaining thought anyway. Projection of consciousness, is it possible to project ourselves into other realities altogether? This basically would provide a logic or a means to do so, or to explain it anyway. I'm not quite sure how to do that, but there have been those that say that they can. All right, dog whistles and active guidance of UAP. Now, this seems to be gaining huge attention. What are we detecting? Verifiable physical objects, projections from another dimension, projections from our own consciousness or other. And how do we detect it? Optical imaging, spectral imaging, other. I've seen certainly spectral and optical. And what do these phenomena include? And this is really important. There's the dog whistle that brings in UAP, directed guidance, but there's also teleportation, remote viewing, influence at a distance, and other. And quickly before I close, is it real? The DIA thinks so. Is it something that you want to tamper with? Is it something that you want to approach naively? And the warnings from the DIA in a previous paper were don't. You may have more than you expect, may encounter more than you expect, and may get more than you bargain for. So just be very careful if you're involved in this. I'm not sure what to make of it myself, but it is food for thought. All right, I have 2 slides, mitigation preparation. You can read these at your leisure. And Tim, that's what I got.